Randomly, this slide is critical reading. The researcher has to account for any sort of missing data. Occasionally, data may be lost, or it might not be good enough for analysis. There might not be enough information. For example, equipment failure or subject attrition. The author should explain what happened and also should comment on the implications of any missing data on the validity of the study, and you as the reader should take note of that. Let's talk about descriptive statistics. A second way of organizing the data, in addition to or instead of frequency distribution, is you can summarize the data in numerical form. You can use summary statistics to describe the overall distribution of the data. This uses a lot less space than presenting the entire frequency distribution. And the summary statistics help to provide the foundation on which most additional analysis techniques are based. The selection of the appropriate summary statistics is important for appropriate analysis of the data. So space is always an issue when you're writing these papers. Summary statistics include measures of variability, so the amount of dispersion in the scores, the spread of the scores, and the variability of the scores. This is known as the indices of variability. Major statistics in this are the range, the variance, the standard deviation, or the semi-interquartile range. The range is the spread of scores from the highest to lowest. A smaller range means there was less variability in the distribution. The variance. The variance is determined by finding the mean of the values in the distribution, and then determining how far each value in the distribution deviates from the mean. The deviation scores are squared because half the deviation is negative, that is below the mean, and the other half is positive, so you square it to get rid of the negative signs. The squared deviation scores are summed and averaged to compute the variance. The variance cannot be presented in its original units measured because of the squaring. Therefore, it's not usually an absolute index of how the data is spread out from the mean, but it's an important number that can represent the variability of the data. And the variance is used to calculate certain statistics, such as the correlation coefficient. Correlation coefficient is used for analyzing relationships among variables. And the analysis of variance, the ANOVA, which is used for analyzing differences between groups and subjects. We'll talk about the difference between analyzing relationships and analyzing differences later, but you need to know the variance before you can do that. So how much do the scores deviate from the mean? The square root of the variance is a useful measure of the average by which all the scores deviate from the mean. So the square root is the average deviation from the mean. The standard deviation is the average amount of dispersion of the scores. So from the variance, we can come down to the standard deviation. The small standard deviation indicates that the distribution does not spread out from the mean very much. The group is relatively homogeneous. A large standard deviation indicates a wide dispersion of scores from the mean in the distribution. Therefore, the group is very different. It's heterogeneous. Interpretation of the standard deviation depends on the normal curve model. So that works when we have a normal distribution, a symmetrical distribution. If the data is not symmetrically distributed, we could look at the semi-interquartile range. This indicates half of the range of the middle 50% scores in the distribution. So if our data is not a nice little normal curve, we have to look at something different, the semi-interquartile range. Skewness is the lack of symmetry in a distribution. A symmetrical distribution is A. It looks the same on left and right. You could have a distribution that's negatively skewed. That would be B. So most of the scores are in the higher area, but then it skews. There are a few scores towards the lower end. C is a positively skewed test, where most of the scores are clustered in the lower end, but then there are a few that kind of pull out to the higher end. So positively skewed is C. Negatively skewed is B, kind of drags to the negative side. The measure of skewness is called the skewness statistic, and it's sometimes used for computing the degree of asymmetry. A skewness statistic of 0 indicates a symmetrical distribution. A positive skew indicates a positively skewed distribution that inflates the mean. A negatively skewed one deflates the mean. Neither type of skewness affect the medians. Remember, the median is how we count our scores in. With skewness, if the mean is greater than the median, it is positively skewed. If the mean is smaller than the median, it is negatively skewed. Finally, we'll talk about kurtosis. This is the general form of concentration of scores around the center of the distribution. So it affects the shape or the bend of the tails of the distribution, and the statistic used is called the curve. It's sometimes used to indicate the degree of kurtosis in a distribution.